everyone, this is Mrs. Snook with section 4.6, graphs of other trigonometric functions. So last time we did graphs of sine and cosine, and we did transformations on those graphs. Today we're going to do the same thing, but it's with tangent, cotangent, secant, and cosecant. So we're going to do 4 different kinds of graphs. First one up is tangent. And the first thing I would like to show you is just the graph of y equals tangent of x. And so to do that, we're going to have an xy table where y is the tangent of x. And then once we have that, we can transform to do y equals tangent of x over 2. So first is going to be the parent function, tangent of x, and then next is going to be the transformed function. So for graphing the tangent of x, we need some points. And actually, we don't use a whole lot of points for these. It's not like last time where we had 5 critical points. First thing we're going to do is find asymptotes. So step 1, asymptotes. And this is because there are places where tangent gets undefined. And so it's undefined where x equals plus or minus pi over 2 and multiples. So we're going to have an asymptote at pi over 2. So I'm going to sketch that one in here. We'll also have one at negative pi over 2. And that right there also happens to define our period. Now here's where the points come into play. If I do tangent of negative pi over 4, you're going to find that that equals negative 1. So I've got a point right there. Tangent of 0 is 0, so I have a point right there. And then tangent of pi over 4 is 1, so I have a point right there. So when I sketch my graph, I'm going to start near the asymptote, go through my points, and then go back to the asymptote. That is one cycle of the tangent graph. And because it's periodic, just like our sine and cosine, it's going to repeat itself. So I'm going to have another cycle over here. Asymptote this time is at 3 pi over 2. That's the multiples I was talking about. And the graph's going to look the same. So I'm going to have a point here, here, and here. Snug to the asymptote, across, and there's that one. Period is, in this case, the period length is pi. So it's not 2 pi, it's pi. That comes into play when doing our transformed function. So last time we said period was 2 pi over b. This time for tangent, period equals pi over b. And our b in this case is 1/2. That comes from our equation x over 2. The coefficient in front of x is 1/2. So now our period, which is pi over b, is going to be pi over 1/2, and that equals 2 pi. So my period is being doubled. So instead of pi, it is now 2 pi. So let's figure out where the asymptotes go. So x over 2 equals pi over 2. And then solve for x. X is going to equal pi. So now my asymptotes, instead of being at pi over 2, are going to be at pi. So I'm going to erase these. Okay, so now let's put in our asymptotes. I'm going to take the blue, and I've got an asymptote at pi. And at negative pi. Now my points between these two, I still have a point at 0, but instead of the 1 being at pi over 4, I'm going to double that. So that 1 is going to go here at pi over 2. And my negative 1, instead of being at negative pi over 2, I'm going to double that. And it's going to be at negative pi over 2. Start near the asymptote, go through the points, and there you have it. So in the blue is our tangent of x over 2. And just like the other one, I can repeat the cycle. I'm going to have another asymptote here at 2 pi. So this is going to be here. And oops. Sorry, our asymptote's not at 2 pi. Oh, let's just not repeat it, because I don't think I have room on the graph to do it properly. Next up is going to be 3 tangent of 2x. We're going to graph that one by hand. So think of it as a parent function. So d plus a tangent of bx minus c. Just like we did before, think of it as a parent function. We don't have a d, so d equals 0. We don't have a c, so there's no phase shifting. There's no shifting up or down. A equals negative 3, so we're going to have a flip and a stretch. And b equals 2, so our period is pi over 2. Let's figure out where the asymptotes go. 2x equals pi over 2, so x equals pi over 4. So now I'm going to have an asymptote at pi over 4, right here. And my period is pi over 2, so I'm another asymptote. I'm going to make sure that the distance is pi over 2. So here's my other one. So right in here, that distance is pi over 2. And then every pi over 2, I will have another asymptote. So add pi over 2 to here. That brings me to here. And then to here. And then to here. And here. And here. And lastly here. So there's all of our asymptotes. Again, I'm going to have a point right here at 0. Now we need to figure out our other 2 points. We have our table from last time. I knew that at pi over 4 I had a 1. But now, because I'm actually compressing by 2, it's not going to be at pi over 4, it's going to be pi over 8. So right about there is pi over 8. And because a is negative 3, this isn't going to be at 1, it's going to be at negative 3. So negative 1, negative 2, right there. I'm going to play the same game on the other side. Here's pi over 8. And instead of at a negative, it's going to be at a positive. So here is what this graph looks like. And I can just repeat the same thing over here. And the same thing over here. See if I can get through the points. And so forth. All right, now the next one we're going to do is the cotangent. So the cotangent looks a lot like the tangent, but it's going to be going the other way. And I'll show you what I mean here. So I'm going to start off with the parent function, y equals cotangent of x. So x, y, have an xy table. Now our asymptotes for the cotangent are values of pi, because that's where cotangent equals undefined. So I'm going to have an asymptote at pi. So let me sketch that in. And just like the tangent, the period is pi, so we're going to have an asymptote here right on the axis, and an asymptote here. And then again here. So for negative pi, we have undefined. And same thing at pi. We need to get some points in the middle here. So let's get negative pi over 2. And at negative pi over 2, we have a 0. And then also at pi over 2 is going to be a 0. And then let's get the cotangent of pi over 4. So pi over 4, we said. That one is 1. And then we're going to have a negative 1 here. Looks like this. Same thing is happening on the other side here. Okay, so that's the cotangent of x. So in the black, cotangent of x. Now we're going to apply our transformation, because we want to do 2 times the cotangent of x over 3. So think in terms of our parent function. So we have y equals d plus a cotangent of bx minus c. And in here, d equals 0, c also equals 0. A, that's that 2. So from here we have a stretch. So our points that were at 1 are going to end up at 2. And then b equals 1/3. So that's going to change our period and our asymptotes. Let's figure out where those are going to be. So for our asymptotes, we're going to use the equation that whatever is in here, we're going to set that equal to 0 and equal to pi. And in our case, it's just x over 3. So x over 3 equals 0. X over 3 equals pi, so x equals 3 pi. So for our transformed function, our asymptotes are going to be at 0 and at 3 pi. So I need to make myself some room over here. I'm going to erase this. I'm going to extend my graph out to here. Right about there would be 3 pi. So here's our asymptotes. I'm going to go ahead and just use a highlighter for those. And then I know that I have a vertical stretch of 2. So when I figure out my points, everywhere there was a 1 is going to be a 2. And I need to stretch these out. Instead of having a period of pi, I have a period of 3 pi. So that means everything gets stretched by a factor of 3. So my 0 point is not going to be at pi over 2. Instead, it's going to be at 3 pi over 2 because I have to apply a horizontal stretch of 3. This one that was at pi over 4, 1, I got to multiply that by 3. So instead of pi over 4, I'm going to get 3 pi over 4, which puts it right about here. 3 pi over 4 is here. And instead of being at 1, it's going to be at 2. And then this one, so I have my curve like this so far. My other one is going to be out here, oops, at 9 pi over 4, which is going to be right about here. So that's going to put it down here. So there we go. That's what our graph looks like. All right, now the next thing we're going to do is the secant and the cosecant. Easiest way to do this, and this is super easy compared to what you're used to, is we're going to, number 1, determine the reciprocal function. So cosecant, the reciprocal function of that one is going to be sine. I'm going to use that reciprocal function, and I'm going to graph the reciprocal function. So right here we have 2 times cosecant of x plus pi over 4. So instead of graphing that, I'm going to graph 2 sine of x plus pi over 4. That's your first step. Switch it to the 2 sine of x pi over 4. So reminder from last time, that means amplitude equals 2. Our period is going to be 2 pi, and our phase shift is negative pi over 4. So my critical points are going to be here. I'm going to start at negative pi over 4. I'm going to go up to 2. I'm going to go down to the axis, down to negative 2. Oops, it's 2 pi. Sorry. So up to here, down to the axis, down to here, up to the axis. So it's going to look like this. And then it keeps going. So on the other side, down there, axis, up there. So remember that? Now for cosecant, once you have that, first thing you need to do is put in your asymptotes. So now step 3 is asymptotes. Those go every place that we cross the x-axis. So I'm going to have an asymptote right here. And I'm crossing the x-axis here. There's an asymptote. Crossing the x-axis there. There's an asymptote. Crossing there. There's an asymptote. So I put in my asymptotes. And then I have a point at the peak or the trough of my sine graph. So start at the asymptote, touch the sine graph, go back up. Start at the asymptote, touch the sine graph, go back down. Asymptote, sine graph, back down. And this is what it looks like. So in the red is the 2 cosecant of x plus pi over 4. And then the last step, 4, is sketch. So easy peasy. If you can sketch the sine and the cosine, you can sketch secant and cosecant. We're going to do this other one next. This is our last example. We're going to do the secant of 2x by hand. So remember, step 1 is identify reciprocal function. Now in this case, it is cosine of 2x. Step 2, graph the reciprocal. So graphing cosine of 2x, amplitude equals 1, period is going to be pi, and C is 0, D is 0, so I'm going to start here. I'm going to end here, and this is cosine, so instead of starting at 0, I'm going to start at 1, and I'm going to end at 1. So there's our critical points. So it looks like this, and it keeps going. Goes the other way. Just keeps going. Step 3 is your asymptotes. Everywhere it crosses the x-axis, I put in an asymptote. So there's all my asymptotes. I'm going to start at the asymptote, touch at the peak or the trough, and then go back towards the asymptote. So asymptote, touch, back. Asymptote, touch, back. Asymptote, touch, back. And just do the same thing for each of these areas. And there you have it. Now we've got the secant of 2x drawn by hand. All right, that's it for today's lesson. Thank you for watching and have a great day.